Hi, Mr. Wright here, and welcome to this film on finding the equations of perpendicular bisectors. Now, this is a really important topic, not least as it involves several different stages. It involves you needing to find the gradient of the line between 2 points. It involves you having to find the midpoint between 2 points. It involves you having to find the gradient of a line which is perpendicular to another. It involves you having to find the equation of a line if you know the gradient of the line and a point on the line. And then it involves you putting all four of those skills together to find the equation of a perpendicular bisector of a line segment. So this is a really good topic. Now, this film is one that I originally recorded for my Get Ready for A-Level Maths series, but it is so useful to those of you who are sitting your IGCSE that I am loading it onto the YouTube channel too for you to access. So here you are. Good luck. Let me know if you have any questions. Leave me a comment. Tell me how you get on. And of course, if you find the film useful, please do share it with anybody else you know who's preparing for their IGCSE maths. And if you are preparing for your IGCSE maths and you haven't already subscribed to the channel, then I really would hit that subscribe button. Right? Good luck with the maths. Let me know how you get on. Hi, Mr. Wright here, and welcome to this film in which we will run through how to find the equations of perpendicular bisectors. Now, this is a great topic for those of you getting ready for A-level maths, as it involves revising and becoming really fluent in four different things. Finding the gradient of the line between 2 points, and then finding the gradient of the line that's perpendicular to that, finding the midpoint between 2 points, and then finding the equation of a line given its gradient and 1 point on the line. Now, all four of these skills are skills which you will want to become really fluent in before you start your A-level maths. Hence, finding the equation of a perpendicular bisector is a really good skill to practice before your A-level maths starts. Right, here we go. Let's first of all look at finding the gradient of the line between 2 points. Okay, so let's have a look at finding the gradient of the line between 2 points. And let's take these 2 points as an example, the point A and the point B written there in red. Now, you're probably thinking that you know how to find the gradient between 2 points, and I'm sure you do. But the idea of this Getting Ready for A-Level Maths course is to find automatic ways of performing things like finding the gradient between 2 points, which involve much less thought than perhaps your GCSE methods involved, so that you can do these things without thinking. Now, let's just backtrack a moment. I'm sure that you've learned how to find the gradient between 2 points, and you may have used a saying such as rise over run, or you may have thought, okay, it's the change in y divided by the change in x. Now, each of those require a little too much thought for my liking and rather too many steps, and so it's easy to make a mistake, and it takes longer than it need. Let's focus on change in y over change in x, and let's remember that you could do y2 minus y1 over x2 minus x1, or you could look at the points the other way around, and you could do y1 minus y2 over x1 minus x2. It doesn't matter whether you do y2 minus y1 divided by x2 minus x1 or y1 minus y2 divided by x1 minus x2, but you must do the same way round on the change in y as you do in the change in x. Right, so here is my quick method which I would urge you to consider using when finding the gradient between 2 points. So, write the two sets of coordinates above each other as I already have for A and B. Now, we know that we're going to be working out the gradient. We're going to start calling the gradient m, but for now I'm going to call it grade. Right, we want to do the change in y over the change in x. It doesn't matter whether we consider the change in y from point A to point B, or the change in y from point B to point A. As long as we do the same when we're looking at the change in y and the change in x. Now, looking at my y's there, I'm going to find it easier to count up from 14 to 29. So the change in y is 15. Now, when I'm thinking about the change in x, I must go the same direction. So the 6 to 11 gives me 5. So my gradient is simply 15 divided by 5, 3. Let's just check I get the same when I go the other way around. So let's imagine that you were desperate to subtract, and so we're going to go from point B to point A. So the gradient in this case will be 29 to 14, that's minus 15. 11 to 6, that's minus 5. Minus 15 divided by minus 5 is 3. So I do get the same. Right, let's practice this automatic method with these 2 points here, the points C and D. Pause the film, work out the gradient. In the meantime, I'm going to crack on. So my gradient is going to be, now I'm going to go from top to bottom here, because I like the look of the 4 to the 14. So top to bottom, 4 to 14, well that's adding 10, and then 5 to 7, that's adding 2. 10 over 2 gives me a gradient of 5. Okay, moving on. Let's look at E and F here. Let's work out the gradient. I'm going to go from top to bottom again. It doesn't matter whether you go from bottom to top or top to bottom, but you must do the same direction with the y's and with the x's. So if I'm going top to bottom, then my gradient, I'm going to think about, right, 7 to minus 3. Well, that's a change of minus 10. 6 to 8, that's a change of 2. So my gradient is minus 10 divided by 2 is minus 5. Okay, now these blue coordinates here, the gradient, now what shall I do? I'll go from top to bottom again, why not? So 13 to 10, that's a drop of 3, so minus 3. Minus 2 to minus 4, that's a drop of minus 2. So in this case, my gradient is simply 3 over 2. Right, so I hope you get the idea. In what's going to follow in the next couple of minutes, I'll do 5 examples really quite quickly and you can practice those. Right, here are 5 examples on the screen. Why not pause the film, do those 5 questions and then watch me do them. Okay, here I go. So this first one here, the gradient is going to be, right, 7 to 10 is a gain of 3 over 6 to minus 5, well that's minus 11. So the answer is minus 3/11. Number 2, I'll go from top to bottom again. So the gradient is going to be minus 3 to 6, that's a gain of 9. Minus 4 to 10, that's a gain of 14. So it's 9/14. Number 3, let's always go from top to bottom, why not? So the gradient is going to be 8 to minus 2, that's a drop of 10, so minus 10. And minus 7 to 1, that's a gain of 8, so minus 10 over 8, which is minus 5 over 4. Number 4, go from top to bottom again. The gradient is going to be, well, minus 4 to 7, that's a gain of 11. And 6 to minus 10, that's a drop of minus 16. So my answer is going to be minus 11/16. And number 5, top to bottom, so the gradient is going to be the change in y, minus 4 to minus 10, that's a drop of 6, so minus 6 on the top. Minus 5 to 15, that's a gain of 20, so minus 6/20, that's going to be minus 3/10. So there you are. So I hope now you can almost without thinking find the gradient of the line between 2 points. Right, let's go on to skill number 2. Right, skill number 2, finding the gradient of the perpendicular line. So, in each of these questions here, 1 to 5, we found the gradient of the line between our 2 points. Now, what about the gradient of the line that is perpendicular to that line? Well, as you probably know, the trick is that we simply find the negative reciprocal of the original gradient. So in question 1 here, the gradient of my line between the points A and B is minus 3/11. So the gradient of the perpendicular line will be the negative reciprocal. So we're going to change the sign and flip the fraction over. Okay, let's do the same here. The gradient of the original line segment is 9/14, so we're going to change the sign, so it's going to be negative, and we're going to flip the fraction over. So the gradient of the perpendicular line is minus 14 over 9. Easy. Change the sign, flip the fraction. 4 over 5. Change the sign, it's going to be positive now, flip the fraction. Change the sign, it's going to be positive, flip the fraction. There you go, and that's how to find the gradient of a line that's perpendicular to the gradient that you know. Now, let's just have a quick look over here, because sometimes folk find it a bit confusing when the original gradient is a whole number. Now, in this case here, the gradient of the line segment AB is 3. So how do I find the negative reciprocal of 3? Well, the answer is that you think about 3 as being 3 over 1. And now it's quite straightforward. Change the sign, so it's going to be negative, and flip the fraction. So it's going to be minus a third. Let's do the same here. Think about that as being 5 over 1. So the negative reciprocal is minus a fifth. Think about this one as being minus 5 over 1. Okay, minus 5 is equal to minus 5 over 1. So the negative reciprocal, change the sign and flip the fraction. All right, and here's the last one, 3 over 2. So we're going to change the sign and flip the fraction. So it's going to give me minus 2/3. So that's straightforward, I hope. And that is how to find the gradient of a line which is perpendicular to the gradient that you already know. Okay, finding the midpoint between 2 points. Again, you probably know how to do this. And again, you need to be able to do it without thinking. So we've got the point A here and the point B written in red, and we're going to find their midpoint. Now, I always set this out in the same way. I always draw a line here, and I always write the midpoint beneath the points. Now, I'm always very careful here because I make sure that this M for midpoint is very clearly a capital M, so I don't muddle it with my lowercase m, which often we use for gradient. Now, how do I find the midpoint between these 2 points? Well, you probably know that you need to go halfway between these 2 x coordinates and halfway between these 2 y coordinates. How do you find a number that's halfway between 6 and 11, for instance? Well, you simply do 6 plus 11 and divide that sum by 2. So that's going to be 17 over 2, which is 8.5. 14 plus 29 is 43. And so if I was going to be lazy, I'd just write 43 over 2. But I think I can manage 21.5. So there's my midpoint between A and B. Right, let's do the midpoint between C and D. So without thinking, I tend to draw a line here, capital M. Right, 5 plus 7 is 12, divided by 2 is 6. 4 plus 14 is 18, divided by 2 is 9. I hope you're doing them quicker than I am. Here's the last 2 for you to do before me. Why not pause the film? Okay, here we go. Capital M. Right, 6 and 8 is 14, so that's 7. 7 and minus 3 is 4, so that gives me 2. Okay, and here we go. Capital M. Minus 2 and minus 4 is minus 6. Divide by 2 is minus 3. 13 and 10 is 23. So 23 over 2. Or of course you could write 11.5. All right, so there you go. That is how to find the midpoint between 2 points. Okay, so now we're going to look at finding the equation of a line if you know its gradient and you know 1 point on the line. Now let's just consider these 2 points which we've looked at before, the point A and the point B. We've already found the gradient between the 2 points. So let's imagine here that the question is, find the equation of the line AB. Okay, now here's the diagram, okay, and I've plotted A and I've plotted B here. And so it would be relatively straightforward for me to draw the line AB. And of course I could extend that as much as I like. So here's the line AB. Now, it is very tempting to think, oh, I'll just find the gradient and the y-intercept, and I'll use y equals mx plus c. The problem with that is that you probably have done this before, and you probably found yourself kind of extrapolating from here and trying to find out what that coordinate is there where your line crosses the y-axis to get your y-intercept. And really, it's a bit of a messy method, to be honest. It takes a long time and it takes a lot of thought, and it only works conveniently if the numbers work conveniently. And needless to say, they're rarely going to work conveniently. So we're going to do it a different way. Now, we have got the gradient of the line AB. It's here. We've already worked it out, and you know how to work out the gradient without thinking now. And we know that the line AB is going to be in the form y equals mx plus c, where that lowercase m is the gradient. So we already know, using the fact that we know the gradient, that y is going to be 3x plus something. Okay, all I've done there is put the value of my gradient into my y equals mx plus c formula in place of the lowercase m. So I know by using the gradient here that my line is y equals 3x plus c. Now, how do I work out what c is? Well, the answer is you've used the gradient, so now it's time to use the fact that you know the coordinates of one of the points on the line. In this case, I know the coordinates of two of the points on the line. It doesn't matter which one I take. I'm going to consider the point A here. Now, the point A tells me, so I'm going to delete B just to make it easier. The point A tells me that when x is 6, y is 14. So that means that I can substitute these values of x and y into my equation here. So instead of writing y equals 3x plus c, underneath that I'm going to write, well, y is 14, isn't it? 14 equals 3 times 6 plus c. Because I know that when x is 6, my equation must give me the answer 14. Hence I know that 14 is 3 times 6 plus c. And so now it's relatively straightforward to work out that c is minus 4. And now I know the equation of my line is y equals 3x minus 4. Okay, and yes, if you did it the really awkward way and kind of extrapolated to find your y-intercept, you would have found that the y-intercept was minus 4. But I would urge you to convert to finding the equation of a line given its gradient and one point of the line, convert to doing it in this way. Right, let's have a look at another example. Let me just delete all this. Okay, and let's have a look at the case of C and D here. Okay, let's find the equation of the line from C to D. You could make a start on that if you wanted to. The first thing you need is you need the gradient from C to D. Well, you've got that already. So now we're going to say, well, we know that y equals mx plus c, and we know that the m, the little m, is the gradient. So we know that y equals 5x plus c. Brilliant, we've used the gradient. Now we're going to use one of the points on the line. Let's use the point D this time. So the point D tells us that when x is 7, y is 14. So I can tell you that 14 must equal 5 sevens plus c. Okay, well 14 must be 35 plus c. So c must be 14 take away 35. So c is minus 21, in which case the equation of my line is y equals 5x minus 21. Okay, let's have a look at the next 2 points. Let's find the equation of the line EF. Okay, let me just give myself some space here. The equation of the line EF. Right, well, perhaps you've done it already, or maybe you'll pause the film now because I'm about to start. So I know that y equals mx plus c, and I know the gradient is minus 5. So y is going to be minus 5 times x plus c. Okay, time to use one of my points. I'll use point E here. Now point E tells me that when x is 6, y is 7. So 7 must be minus 5 times 6 plus c. So 7 equals minus 30 plus c. So c must be 37. So now I know the equation of my line is y equals minus 5x plus 37. Okay, have a go at G and H. This time the gradient is slightly more complicated. Okay, pause the film and have a go. Or work alongside me. I'm going to make a start now. Now I know that y equals mx plus c. And I know the gradient is 2/3. So I know that the gradient is 3/2. So I know that y equals 3 over 2x plus c. Right, I've used the gradient. Time to use one of the points. I'm going to use the top point. So that tells me that when x is minus 2, y is 13. So 13 must equal 3 over 2 times minus 2 plus c. Okay, well that means that 13 equals minus 3 plus c, so c must be 16. So the equation of my line is y equals 3/2 of x plus 16. Okay, so now I'm kind of hoping that you, without thinking, can work out the equation of a line if you know its gradient and you know one point on the line. Okay, so now we're going to put all those skills together to find the equation of a perpendicular bisector. And the example we're going to look at here is that we have got the point C and the point D. You can see those top right. And we're going to find the perpendicular bisector of the line segment CD. So I've started off here, and just to make it easier this time round, I've drawn a diagram. And there I've just drawn the line segment CD. Now we need to find the equation of the perpendicular bisector. Now, two things. Clearly, the perpendicular bisector is a bisector. So it crosses the line CD, it crosses that line segment halfway because it bisects it. So it is not going to go through here. All right. Instead, it has to go through halfway. It has to bisect the line CD. So it's going to go through the midpoint of CD. It's going to go through this point here. Okay. Now, secondly, of course, it is a perpendicular bisector. So that red line there, it may well bisect CD, but it doesn't bisect it at right angles. So that red line is not the perpendicular bisector. It's just any old bisector. So instead, let's have a think about what that perpendicular bisector would look like. Well, it's got to go through the midpoint, through that yellow point, and it has to be at right angles to the line. So it's going to look more like that. That's not a bad sketch, is it? That would seem to me to be, that red line would seem to be perpendicular to the line segment CD and also goes through the midpoint. So it's that red line here that we need to find the equation of. Now, to find the equation of a line, we need to know a point it goes through and also its gradient. Do we know the gradient of the red line? No, we do not. But do we know the gradient of the blue line? Do we know the gradient of the line segment CD? Well, look top right here. Here are the coordinates of C and here are the coordinates of D. And so I'm going to find the gradient. I'm going to use lowercase m for gradient. And I know how to do this. I'm going to do 4 to 14. I'm going to go from top to bottom. So 4 to 14, that adds on 10. 5 to 7 adds on 2. Look at that. The gradient of the blue line is 5. Okay, so now do I know the gradient of the red line? Well, the answer is of course I do, because the gradient of the red line is the negative reciprocal because they're perpendicular. So if the gradient of the blue line is 5. Well, that's the same, of course, as 5 over 1. Then the gradient of the red line is the negative reciprocal of that, so it's going to be minus a fifth. There you go, I know the gradient of the red line. Do you know a point on the red line? Because if you do, then you can work out the equation of the red line. Well, I know the red line goes through this yellow point, which I've marked there, that yellow point there, and that's the midpoint of CD, isn't it? Okay, up to the top, you can see that I have got the coordinates of CD here. I'm going to find their midpoint. I'm going to draw a line underneath them. I'm going to use a capital M, so I don't confuse it with my lowercase m. 5 plus 7 is 12, divided by 2 is 6. 4 plus 14 is 18, divided by 2 is 19. Look at that. Divided by 2 is 9, sorry. That point there, the midpoint there, has coordinates of 6, 9. Now, let's have a think about the red line. Do I know its gradient? Yes, I do. It's minus a fifth. Do I know a point on the line? Yes, I do. A point on the line is the point 6, 9. So, what I've got to do is I've got to find the equation of a line which has a gradient of minus a fifth, and I know a point on the line is the point M, my midpoint. Look at that. You see how easy it is to muddle your lowercase and uppercase m's, especially with my writing. So that's the gradient there, and the midpoint is 6, 9. So I'm writing down the equation of a line which goes through the point 6, 9 and has a gradient of minus 5. Okay, well I can do that automatically. Y equals mx plus c, and I know in this case that my gradient is minus a fifth. So y is minus a fifth x plus c. I've used the gradient, now I'm going to use the point. I know that when x is 6, y is 9. So I can write 9 equals minus a fifth times 6 plus c. So 9 equals minus 6 fifths plus c. So c is going to be 10 and a fifth. So what is the equation of my perpendicular bisector? It's going to be y equals minus a fifth x plus 10 and a fifth. And that is how to find the equation of a perpendicular bisector. It combined all the skills that we've just learned how to do without thinking too much. And that means that if you practice this, you can find the equations of perpendicular bisectors, following through each of those skills without thinking too much, and thus write down the equation of the perpendicular bisector of 2 points without thinking too much. All right, time to practice some, I think. Right, so here are 2 points, A and B. Can you find the equation of the perpendicular bisector of the line segment AB? If you know how you're going to make a start on that, pause the film and make a start. If you want to watch me to start with, then I'm going to start solving that problem now. The first thing I'm going to do is I'm going to find the gradient of the line segment AB. So lowercase m, I'm going to go top to bottom. So 14 to 29, that's a change of 15. 6 to 11 is a change of 5. There you are, the gradient is 3. And I'm also going to need to know the midpoint of AB. So capital M, my midpoint is 11 plus 6 is 17, 17 over 2, comma, 14 and 29 is 43, so 43 over 2. So there's my midpoint, and there's my gradient of the line segment AB. Now let's have a think about the perpendicular bisector. The perpendicular bisector is definitely going to go through that midpoint. So that's the point 8.5 and 21.5. And the gradient of my perpendicular bisector isn't going to be 3, it's going to be the negative reciprocal of 3 because it's at right angles to the line segment AB. So the gradient is going to be minus a third. Now I know a point on the perpendicular bisector, and I know the gradient of the perpendicular bisector, so I can work out its equation. So I know it's going to be y equals mx plus c. So I know that's going to be y equals minus a third x plus c. Now let's use the point. I know that when x is 8.5, y is 21.5. So 21.5 equals minus a third times 8.5 plus c. So I'm going to do a third of 8.5 and add that on to 21.5. 8.5 divided by 3 equals plus 21.5 equals, gives me a C of 73 thirds. So now I know the equation of the perpendicular bisector is y is minus a third x plus 73 thirds. I hope you got it. If you didn't get it, I hope you understand where you made a mistake. Right, let's have a look at another example. Okay, this time let's focus on the points E and F. All right, so we're going to find the equation of the perpendicular bisector of the line segment EF. If you know what you're doing, pause the film and carry on without me. Right, the first thing I'm going to do is find the gradient of the line EF. So I am going to say little m equals, right, I'm going to go top to bottom. 7 to minus 3, that's minus 10. 6 to 8, that's 2. So the gradient of the line segment EF is minus 5. What about the midpoint as well? So capital M. 6 and 8 is 14, so that's 7. 7 and minus 3 is 4, so that's 2. So I know quite a lot about the perpendicular bisector now, because I know it's going to go through the midpoint, 7, 2, and I also know its gradient. It's not going to be minus 5, it's going to be the negative reciprocal of minus 5. It's going to be a fifth. So now I've got a point on the perpendicular bisector, and I've got the gradient of the perpendicular bisector. So I can go ahead and write down its equation. Y equals mx plus c. So I know that's going to be y equals a fifth of x plus c. Now I know that when x is 2, y is 7. So I know that 7 equals a fifth times 2 plus c. So I know that 7 equals 2 fifths plus c. So I know that c is 6 and 3 fifths. So now I know that the equation of the perpendicular bisector is y equals a fifth x plus 6 and 3 fifths. And there you go. Getting easier, I hope. Let's have a look at another. Okay, last one. Let's find the equation of the perpendicular bisector of the line segment GH. If you know what you're doing, pause the film and on you get. Right, I'm going to start by finding the gradient of the line segment GH. So little m will be, let's go top to bottom. So 13 to 10, that's minus 3, over 2 to minus 4, that's minus 2. So my gradient is 3 over 2. And what about the midpoint between G and H, the midpoint of GH? Let's have a look. Capital M. Minus 2 plus minus 4 is minus 6, divided by 2 is minus 3. 13 and 10 is 23, divided by 2 is 23 over 2, 11 and a half. So now I know a fair amount about my perpendicular bisector. I know it goes through the point M, that midpoint, which is that, and I know it has a gradient of what? Minus 2 thirds, the negative reciprocal of 3 halves. So I know that my perpendicular bisector is going to look like y equals mx plus c. So y equals minus 2 thirds x plus c. And I know, by looking at the coordinates of that point M, that when x is minus 3, y is 11.5. So I can write 11.5 equals minus 2 thirds times minus 3 plus c. So that means that 11.5 equals, what's that going to be? 6. Is that right? No, it's wrong. It's going to be 2 plus c. So that means that c is 9.5. So now I can write down the equation of my perpendicular bisector. Y equals minus 2 thirds x plus 9.5. And there you go. So that is how to find the equations of perpendicular bisectors. Thanks for watching. See you in the next film.